Okay. Now we go for the first panel. It's called Connecting Research and Impact. And we will have 4 presentations. One presentation is, the session will be chaired by Pedro Wongtschowski. Please, Pedro, come in. And I would also to invite José Eustáquio, Ribeiro, Vieira, Filho from the IPEA. He's going to present a study he did about the impacts of funding, research funding in agriculture, about FAPESP. All these 4 presentations that we have now use data from FAPESP in order to talk about impacts, multidimensional, societal impacts, economic impacts, health impacts, etc. Professor Mário Salerno from the University of São Paulo. He's going to present a study about our SBIR, Small Business Innovation Research Program, which is called here PIPE, P-I-P-E. Mário Salerno. Professor Luciano Coutinho from the University of Campinas, who is going to show us methodological development about how to measure impacts in the health system, health area in general. And finally, Evandro Coggo from Unicamp and Bernardo Cabral. I don't know if you are going both here, or what did you decide? Yeah, both? Please, where is Bernardo? Bernardo is also there. They are going to present a study of how FAPESP-funded research impacted public policies. Okay? So thank you, everyone. I give the word to Pedro Wongtschowski.
Good morning, everyone. It's a pleasure to share this first panel. And basically, the objective here is how we connect research and impact in 4 different sectors: agriculture, small business, health, and public policies. And for that, we have the privilege of having 4 outstanding speakers. So I start, please, with José Eustáquio, Ribeiro, Vieira, Filho. Please.
First of all, I'm glad to be here. I apologize about my English. It's not so good as my colleagues here. I know that we are in Brazil. We could speak Portuguese, but for our colleagues from outside Brazil, I try to speak in English, and my presentation could help us to see the data and the things that I will present. Thank you so much for FAPESP to invited me 2-3 years ago to do this kind of research. And our first goal before start this project is to measure the impact of expenditures of FAPESP in the agricultural field. So I also thank you, Professor Sérgio Salles, that participate with me in this connection between FAPESP and also in this meeting. So our research was published in 2 different journals. Pesquisa e Planejamento Público is a journal from IPEA, and also Revista Brasileira de Economia from FGV is another journal. And the title of my presentation is Science and Technology in Agricultural Productivity. I'm José Eustáquio Ribeiro Vieira Filho, a senior researcher at the Institute of Applied Economic Research, located in Brasília, the capital city. Okay. My presentation is divided into 3 parts. The first, it's the methodological part. The second, we are going to analyze and discuss the main results. And final, I have some remarks about our results. The first methodology is to measure the total factor productivity. We use the index to estimate the value of total factor productivity. And the output growth not explained by input growth is basically the residual factor that we are trying to measure. And sometimes my colleagues, economists, try to use this index to relate it to the increase of technology or something related to technological change. But when we analyze the rate of growth of total factor productivity, we should have a different view of this. So it's not the size of the growth, but we need to interpret differently. Why I'm trying to say? Because one of our results show that the total factor productivity in São Paulo is the total factor productivity in the whole of Brazil is much more higher than that we found in São Paulo state. And I will try to explain this after. The second methodological framework that we use was a vector autoregressive model to try to explain the impact into the variables that we are going to analyze, such as research support, science, and rural extension, and also training and capacitation of human resource. The database that we use for a long period of time, around 50 years, because we studied from 1974 to 2020, so it's around 50 years, and we use different databases for the 2 different methodologies. The total factor productivity, we use land, pastures, value of production, quantity of producer, labor, wage, capital stock, fertilizer, pesticide, from different kinds of institutions like IBGE, IEA, RICE, ANFAVEA, ANDA, and also FAOSTAT. For the VAR model, we analyze also, in the first methodology, we estimate the total factor productivity for the entire period, and then we related this index to other other variables like research support, science training, and extension spending from different kinds of institutions. CAPS, our CAPS and CNPq is like NSF in United States. FAPESP is a kind of institution here in São Paulo. Embrapa is a research brand, applied research brand in Brazil, and we have also a unit of Embrapa in São Paulo. IPEA, and different kind of university, USP, Unesp, Unicamp, and also CPS and CAT from Rural Extension Services. And the agricultural production in São Paulo, we studied 21 products. The main products are sugarcane, corn, soybeans, coffee, orange, beef, and chicken meat. In 1974, these main products represented 62%. And in 2020, the main products represent 82%. In sugarcane and orange productions in 2020, São Paulo was the main Brazilian producer. The land use information in São Paulo, if you count agriculture and livestock production, the land was reduced from 16.6 to 15.2 million hectares. And at the same time, the reduction in the land use, we saw a higher productivity, even in yields. For example, corn, soybeans, and oranges grew by 2.2%, 1.7%, and 1.6% per year from the entire period. And this is there is also a greater livestock intensification. The stocking rate range from 0.9 to 1.7. If you compare to the national index, it is 1.1 in the last year. Probably in 2020. We have another study in IPEA that we try to measure the share of technology in the growth of production. And to an increase of 100% in gross production value, technology was responsible for around 60% of this growth. And if you compare the 1995 to 2070, the share of labor decreased over this period of time from a third part of this growth to 19.5% in the last agricultural census. So technology is the main important variable to explain the growth in agriculture, Brazilian agriculture production, and of course in the São Paulo state. Finally, the result of total factor productivity in São Paulo. In this period from 1974 to 2020, productivity grew by around 67.6%. On the other hand, the product index, as I mentioned, 21 products studied, grew 77.1%. And finally, the input index, I mentioned labor, land, capital, pesticide, and fertilizer, explained just only 5.6%. So we have a huge increase of productivity in this period of time, but compared to Brazil, is much less. And if you see, is a flat after a long period in the second part of this time. In an international comparison, we put France, Argentina, Australia, São Paulo, India, Spain, USA, an average of the world, and Germany and Brazil. The total factor productivity in Brazil is 2.7%. But this is the rate of growth of this index. Sometimes the economists say that, okay, so if you have a high rate of total factor productive growth, it's a good index to explain the technology. But if you try to understand a little bit more about the situation, São Paulo is a good state in the agriculture production, in the cutting edge of technology in this field, but the growth of total factor productivity is a little bit less. But why? If you have a space more homogeneous, it's better. You can understand that this is not higher than we expected. So it's not the size of the growth, but it's to understand. If you are in the cutting edge, it's of course your growth will be less than compared if the entire country that the agriculture is heterogeneous situation. So because of that, I try to. And FAPESP expenditures on share in the area of agricultural science, it's around 22% over this period, and in the research funding, it's 95%. So FAPESP has a central role in this policy in the state of São Paulo. The absorbed capacity of technology, expenditure, such as funding, science, training, and rural extension, in millions of reais, we can note that the series analyzed here are not stationary and having some stochastic tendency, as well as the existence of possible structural breaks. For example, the extension had a drastic drop from 90s to the beginning of 90s. The survey has a large fluctuation through the entire period. Different kind of governors from the 70s to nowadays play different roles. So it's very hard to measure the impact from a long period of time that you have lots of change during this period. And the first model, we separated training, science, extension, and research support, and compared the impact in the total factor productivity. The training has some impact, but the others variables, not so much, science a little bit, but the response to the shock is practically explained, of course, by the total factor productivity, but 26% by science, 9% by training, and 2% by extension in this model. The second model that we tested, we separated training, science, and extension. Training, we have some impact, science, a small curve, and the extension, we don't have impact in this model. And the decomposition of variance error, the response to the shock was practically explained in the fourth period by 57% by total factor productivity itself, by 25% in the science, and by 14% in training and by 2% in rural extension. And the third model, that was the model that fit better, we agglutinated science, training, and funding research in one variable called science and technology, and extension separated. We have some impact in the science and technology variable, and a little bit in the extension variable. And the shock was explained, total factor productivity itself by 62%, 34% by science and technology, and by just 4% in rural extension. Here are some books that we published from the past 15 years, and I put here the two papers published supported by FAPESP. Produtividade total dos fatores no setor agropecuário de São Paulo, it was published in the Planejamento e Políticas Públicas, and Ciência e Tecnologia nos ganhos de produtividade da agropecuária. It was published in the Revista Brasileira de Economia. Thank you so much. And
Mário Salerno, please, I invite you to your speech.
Hi, thank you for the invitation. FAPESP is quite important. In my career, I have always been financed by FAPESP, so I was at home. I don't remember exactly thinking of the next soccer game or quantum physics when Sandro Lana phoned me. Hi, how are you? What do you think about doing a job investigating about PIP, our SBIR program? So we started discussing, and then Sinesio as well, what could we do? And we decided to do that. There are lots of papers, researchers on such kind of evaluation, on economic evaluation, on the tax returns, on the growing in employment and so on. But they asked me, how do companies use the research, the resource? What is going on inside companies? So we decided to go to an in-depth interview with entrepreneurs of these companies, and then a survey with the beneficiary companies to try to discuss the causal factors for the success of these companies. Okay, I will arrive at it. So there's two jobs. The first one, we interviewed business leaders in 16 companies beneficiary from PIP. These companies were selected after independent thoughts with FAPESP consultants of PIP. Then we made a kind, which company one suggests, which company the other suggests, we discussed. Then we discussed again with Sandra and Sinesio, and we arrived at a panel of 14 companies, and then we had 2 others because we have the chance to do that. There was no, we didn't select by sector, okay? Sector was not important at that moment. So different industries, you'll see the list in the next slide. We went through the traditional way to documental analysis, and then we made the interviews, and the interviews were analyzed by the so-called Joya template. It's a kind of, to say, new methodological way to analyze qualitative work. Okay. These are the companies, okay? They're lacking one. And, you know, they are all mixed, all kinds of sectors. Okay. This is the beginning of the analysis. It's in Portuguese because all the interviews were in Portuguese. This is a piece of the Joya template. So here in the first column, there is what they said. We went through a discourse analysis, and we choose this speech. Then we went to a convergence, and then the convergence of the convergence to arrive at the constants. Okay, that is the method. But I think one of the rich things is some statements that these entrepreneurs told us during the interviews. For instance, without people, I wouldn't even open the company. The scholarships were essential. Results helped us to take technological risks, and so on. Two things drove our attention. First, I didn't thought of it, but FAPESP press system. You know, the review of FAPESP, the FAPESP agents of news, and so on. It was all the entrepreneurs told us that this was quite relevant for them to get in contact with investors and so on. For me, it was a surprise. Okay, I'm the reader of the things of FAPESP, but I have never thought that this was so important in their thinking, okay? And the second one, it's more, we can figure out, is that for investors, FAPESP seal was a kind of approval for technical terms. Okay, FAPESP has approved, so we don't have to discuss much on the technicalities of the solution, to say, okay, because there is a seal. And that was another thing. So after that, I found some investors that I know. Is that correct? They said, yeah, that's correct. Okay, so this impression, we try to see the other side of the investors. Okay, so this synthetically speaking, PIP enables the company to survive in the early stages, assist in the establishment of the business pillar. This is quite important. I don't know in other countries, but maybe in Brazil it's changing, but the innovation managers have no formation of management. So it's quite confusing. And when FAPESP links the finance for the development of the technology with business development, this works well, okay? The FAPESP's credibility endorses the technology for the relationship with third parties, investors mainly, and of course, PIP enables the development of technology-based solutions, okay? Well, that is the conclusion of the first part. With the first part, these interviews, we went to a survey with all the PIP beneficiaries, okay? So we made the traditional way. Went to the literature to see what the literature says about critical factors of success for this kind of companies and so on. But the literature treats the variables individually. There's a paper that talks about the age of the age of the entrepreneur, the other on the scholarity, the other, and so on. Okay, so we took one meta-analysis by Song and other guys. we chose two business performance, two measures of business performance, and three questions derived from interviews we made, and we added one question on other official supports other than PP official supports. Then we made the tests and so on, and we decided to analyze it through, to say, new methods come from the political discussion, the political science, that is quantitative comparative analysis or coincidence analysis. It's a methodological nightmare. So if you want me details of the methods, please ask me in the coffee, because it's okay. So FAPESP sent a mail for the company saying that we are going to get in touch. At the end of the day, we had 330 questionnaires approved for analysis, okay? Some descriptive statistics, the age of the companies, they are quite new. Some have companies, 28% had no income at the time, okay? 46 spun off from university programs. I mean, some guys that were working in a lab in a university is not necessarily a formal program for spin-offs, okay? But it was related to the activities these guys were doing in the university, okay? They had IPEA assets, and 70% have participated in other programs than people, mainly incubation programs in the universities and so on. Well, some descriptive statistics. PP transfers credibility for the company. It's the same that in the interviews. Help build the infrastructure to develop the project. Help to form a team. Help to professionalize the company's management, the business side of people, at least for some companies, and favoring participation in PIP helps to get other kinds of funds, and helped companies to gain access to clients, and for some case, helped companies to go in operations outside Brazil. Okay? Summarizing these characteristics, the maturity level of these companies were, and the founding and the management team, they are mainly independent entrepreneurs, okay? That was expected. The company size, they are quite young, to say. They are not, they are very small companies, but they are expected to be. And the challenges they face is the complexity of the I thought was my time was over. Complexity of the progress being developed. IP, it's always an issue, but as well as operating in a nascent market. They don't know exactly how to do it, okay? Let's go to the analysis of the survey. We use a configurational analysis. It's a nightmare, but it's quite interesting because, you know, there are two branches, a huge discussion of which branch of analysis is the right one and so on. But it permits, if this method is right, it permits to identify the causation of an output. Then it's not like the traditional regression models that you only arrive at correlation. You can, by causal logics and Boolean algebra, you can arrive at the causes of the of a phenomenon. And you can work with not independent variables. You know, when you are doing regression analysis, you must assure, theoretically, you must assure that variables are independent. But in management, let's speak, there are no independent variables, okay? We're trying to adjust the data, but theoretically speaking, there are no independent data. So this approach seems quite interesting to do this research. After a long trial and some experience, we decided to use the CNA approach, okay? Because it seems much interesting for us than the QCA that's much more used in research right now. So the results, isolating the items. The main success factors are, 1, investment, okay. 2, achieving a good technology and performance. If the technology performs well, there is a chance that the company goes on. And 3, developing external skills, and in this case, because they are all PP companies with support of PP, and forming an alliance in R&D. Okay, not surprising. Now the configurations. What's the meaning of the configurations? Which combination of factors leads to success? Okay, and it may be also variable 1 plus a bit of variable 2 and the absence of variable 4. Okay. So first, obtaining investment. Okay, it's quite equal to success. 2, succeed in developing the technology and in internal skills, both at the same time. 3rd, R&D alliances and success in developing the technology itself. Both at the same time, okay? So these are the configurations we arrived. We are now, and we can, then we made a relationship with the interviews, and the interviews support these results. And then we are still working on, trying to explore other possible ways. This kind of a processing took 10 days. Okay, it's a technological nightmare. So we have to join variables. So now we are trying to join variables in other ways to see other results. Okay, it took a long time. And maybe we are going to some parts of the universe to see if we can categorize, these are deep techs, that are agro techs, that are fintechs, to try to see if it's possible to have some sectoral results, okay? And that's it. We are quite modern. You have the QR code. If you want to look at our lab, please take a photo. Okay, thank you very much for your attention.
Thank you, Professor Salerno. I now invite Professor Luciano Coutinho of Unicamp for his speech.
Okay. So good morning, everyone. Thanks for the invitation. I was not advised that we were presenting in English, so my presentation is in Portuguese. But this is an attempt to compute a social rate of return in health, in the health area. And that was a challenge that Dr. Pacheco asked me to respond. And I should say it was a big headache. It was very difficult. But we succeeded in one case. And I wish to, in the end, present a few lessons for FAPESP and for the Brazilian science policy, evaluation of policies, of how to enhance the possibilities of computing the impact of science and technology for social needs. So let's go direct. We first had a question. The big question was how to demonstrate the impact of the science and technology investment in health, and particularly FAPESP's investment, specifically FAPESP investment in these. Methodology and case selection, so that's we go through methodology, the objective, the questions, the objective selection of cases, and how we proceeded the investigation results and comments. That's our. So the big initial question was how to compute a social rate of return of a particular innovation funded by FAPESP. So it was not entirely unspecific question, it was a specific question in the health area. So our first challenge was to identify cases that could be viable, in which measurement could be viable. And second was to adopt a specific technology for computing the impact. And that was entirely complex when we're talking about health. And I remember when I was a young economist, and I used to like very much econometrics, and how fantastic and easy it was to compute either productivity gains or production impact and production returns in the agriculture sector, because we had particularly for crops, we had a very specific new, how do you say, semente? We had a new seed, and was very specific, and then the adoption of these was very easy to compute because it's a pattern and in a specific state or area, and the productivity gains easy to measure. So there was was either by Embrapa or from the private sector, and was easy to compute. So it was a fantastic methodology. Professor Grillix, that you as an economist know, all econometric economists have to start with Professor Grillix equations. So, and in these is entirely different. It's very complex. So you have concurrent causations. It's not simple. Health is complex process, different causes, different factors. So it's very hard to identify, in the theoretical question of statistical inference is very difficult. So, and that is why we had to do a broad research And we found that in England, in the United Kingdom, many interesting research in this specific area. But it was, in the case of England, was interesting that they were concentrated in cardiovascular cardio research or in some specific kinds of cancer or in some specific diseases. And it was also a specific based evaluation because you had the research funding, universities, research centers. It was fairly easy to have in their cases, in those cases, the specification of the amount of investment and then the impact on curing the diseases was also facilitated by the statistics of the National Health Services. So even though it was not easy for them to reach those results, but I think the most advanced methodology that we, after doing a big research, was in England. And interestingly, rates of return, rates of social return, is evaluated by how many lives you save. And you have to find a way to give a price or for those flow of lives of people that survive and their economic contribution to society through a form of attributing a flow of income generated by those survivors. So that was the methodology. So you have, and then it comes in the end to a very straightforward way of computing a rate of return. So, but it is not a private rate of return. It's very easy to compute private rates of return because then you have a corporation. Corporation does its own R&D. Maybe part of these R&D is funded by public funds. Most of them is funded either by tax incentives or by direct funds, by public funds. And then the corporation has a patent or a product or a drug, and it sells the drug and has a profit. So, and the whole corporation has the data in itself because it has the flow of profits. So it's very easy for them to compute rates of return. Yeah, it's entirely different to compute rates of return for public, for communities, for survivors, for in a complex, particularly in a complex process. So we had to struggle to replicate those rates of return that were computed to. And one key concept is the number of survivors and the time span of their lives. So we have to adopt some reasonable hypotheses about how long survivors will live. And also we have to adjust the quality of their life. And so a key concept was 1 year of life with full health. And then we must adjust because some of the treatments and some of the disease do not allow a 100% health after. So we have to adjust for life quality after the therapies. And so it's these AVAC is years of life with adjusted life quality. So this is a key variable for the process. So, and then we had to select cases. And we went through a number of cases. So we had to conduct a number of interviews with many entities. And I want to thank them. So, and those entities were in the state of São Paulo, mostly, University of São Paulo, University of Campinas, Instituto Butantan, the Instituto Dante Pazanesi, INCOR, etc. So in the leading hospitals, also the research like Sírio-Libanês, etc. So we had many interviews. And we started covering a big range of innovations, from heart stents to many different, in different areas. So I wish to thank all the research teams and leaders and very distinguished professors that were very cooperative in providing to us many of these. So we focused in 22 cases and tried to find. And we had to find the cases that, first, the innovation was ready and was clearly had a patent or had a intellectual property established. Second, the innovation had to be approved by an authority in the case of Anvisa, in the case of Brazil. And then this innovation had to be, for a long time, in place such that the impact in terms of saving lives could be measured. And fourth, so it had to be funded by FAPESP, or at least FAPESP have to give a substantial contribution for these. And finally, we had to, and then the last case was the most challenges. We had to find a database that had collected the cases and had the measurement of the impact on the lives of those people, of the survivors. So was so out of the 22 cases, and we had 3 cases that seemed promising, and then in the end, we just had 1 case. So it's less than 5% of the whole cases that we were researching. Maybe we could find more, enlarge the selection of cases. So I'm just telling how the process was, and I'm not worrying too much about the sequence here. So let me skip. So I think I've spoke about these. We initially had cardio, cancer, and virology, vaccines, etc. So we focused on many of these. And then, no, we found 4 of the 22, we just found 1. And that case was, I had to translate, that's why my cell phone was, because I wasn't sure about the precise translation of leucemia lymphoide aguda. So it's lymphocytic leukemia acute lymphocytic leukemia in children. And that was a very severe. The death toll 5 decades ago was 85% in children. It was very severe. And after 5 decades, overall, the death rate went down to 10%. So survival rate increased. Absolute cure after 5 years, about 75%. Maybe could be higher, could reach 80%. So it is a complex thing. So we had to find, in that, the differential of this case, that there was a database. And then I will explain why having a database was so important. And then we had to find, during the process of evolution of this treatment, and that was not a specific innovation. It is a protocol of drugs, a cocktail of drugs that was evolving over time, and over time, many new drugs, better drugs, more, less toxic drugs were being developed. And, but the cancers are very individual specific. So the protocol is how to fine-tuning the cocktail for each individual over time. And that requires observation of the reactions of each patient over time. And that's why the innovation is a kind of a process innovation along a period. And then we found out that in a particular, in the late, mid-90s to onwards, until 2017, roughly from the year 2000, there was already 7 years of experience of a specific cocktail. I'm using the term cocktail, but it's not clearly adequate, but a protocol was funded, substantially funded by FAPESP. And it had other donors also, particularly Fundação Banco do Brasil and Motorola company that provided computing power for the groups. So, and then we found this case. And then we selected that time span in which FAPESP funded these, and then we had to observe the impact in that specific population of children that were treated. So, and that was, that's the history of the protocol from 1980 to 1909, and that specific yellow part was the part that was funded by FAPESP. So it was not a revolutionary technology or development that was funded by FAPESP, but it was in the end of it was already roughly mature, but was an incremental kind of development, because in that step, there was a substantial gain. The rate of survival jumped from 70 to 79%. in that time, in that 10 years. So it was relevant in terms of impact by FAPESP. I'm closing, no? So I know I don't have a time left. So we were able to compute. I have all the forms, mathematical forms, but it's quite complex. I can't show. It is in the paper, the forms. But interesting enough, that was the rate of return was quite high as compared to the British studies. In Britain, the rate of return went from 10% to 15%, depending on the case. Here we had a 23%. Was quite high. I don't think the 2-point comma after it, so it's but it was pretty high. Why so? In this case, when you save a life of a child, 9 years old, 5 years old, he has a long time for survival. So the impact projects into a long time period ahead. That's one reason why the rate of return is higher. The other is that in this case, we could not compute the contribution to the investment of the institutions, the universities, salaries of professors, basic infrastructure of the universities that were crucial for the process was not computed. So it is, if we had computed all the public investment implicit in the infrastructure and professors and researchers funded by São Paulo universities, the rate of return would be slightly lower. Even though this rate of return, it could be 18, 20%, even if we give, let's say, a 30% increase in costs for accounting for these. So there are adjustments that can be made, but it was a very interesting and very clearly measurable rate of return. Why? Why was this possible? Because a very important thing, there was a organized ecosystems. This innovation was an innovation that was multi-center, was not just one particular research center. It had 5 research centers at university. Here, 2 centers in São Paulo city, at USP and at Unifesp. There was also Ribeirão Preto, how do you say, Black Little River. Black Little River, it's a city in the hinterland of São Paulo University. And also Unicamp. So in those centers were coordinated by the Hematology Society of São Paulo. And there was a group, and there was a leading professors that decided to cooperate. And those experiments were cooperative in those centers. And in a certain point, one of the leading ladies in this process, Professor Sylvia Brandalize of Unicamp, she decided to create a big database and hired a data manager. And this woman, this data manager, she established a pattern. She discussed with all the other centers, and so everyone adopted the same methodology. And because of this coordination and having the same methodology, it was possible to share, not just share, but divide and specialize the research tasks among them, and then share the observation with the advantage of having a larger base that would facilitate these statistics for every one of them. So it was much easier for each of these centers to improve the protocol because they had a larger. So because it was an obvious benefit for the group, there was a strong incentive for them to coordinate. But there was also a methodology, a metric, very clear, developed among the researchers and shared among them. So my time is over, but I'm sorry because what are the lessons? The lessons are that whenever FAPESP should fund when a specific innovation reaches a level of application, some form of accumulating data in an organized way, in a shared way, such as to measure social impact, either in terms of lives saved or in other impacts in terms of quality, improving the quality of life. So, and the only way to demonstrate this in a very tangible way that economists could understand, which is the rate of return, which is intuitive for us that there is a return, but I think the different is to have an objective measurement of these, should be something in which we should have a specific focus in developing. And I think in the health area is the area that is more complex than others. So if we could develop for the health, it would be easier to adapt to other areas. So I'm sorry for extrapolating my time. Thanks.
Thank you, Professor Coutinho. Let's hear now Evandro Coggo from Unicamp and Bernardo Cabral from Federal University of Bahia.
Hello, everyone. Good morning. My name is Bernardo Cabral. I'm a professor at the Faculty of Economics in the Federal University of Bahia. And I'm here today sharing the stage with my colleague, Dr. Evandro. And we're here sharing our results of one of our many initiatives at the umbrella of the research at LabGeop. So today we're talking about measuring the impacts of FAPESP-funded research on public policies. So first, discussing our context and motivation. We started doing this research because we were trying to answer, we're facing this discussion on increasing skepticism about science, social benefits, especially in Brazil's universities. It's common to hear, what are you doing with public money that comes from the public to your research? So what is happening there? So with that in mind, we started to discuss the science policy interface, or how science is impacting policy, in trying to try different ways to measure that. So, and because we're working with FAPESP a lot in this topic, this was a priority topic for FAPESP, as it should be, the impact of its research on public policies. So with that in mind, we started using a database called Overton. Overton is a database, a proprietary database that holds millions of policy documents in its database. So they define these policy documents as documents that are published for policymakers or by policymakers, and they have all of these millions of policy documents there. And we decided to test an innovative approach to track policy impact using data from FAPESP and data from Overton. This research was already published in the Quantitative Science Studies in the beginning of this year. So I invite you all to read the full paper. It's open access. About the method of this research. So this research was conducted with a lot of debate with FAPESP. As I mentioned, FAPESP was very interested in the relevance of its finance programs in public policy. And FAPESP has a database, BV, a virtual library in English. It has information on all articles that was published using FAPESP funding. There was a lot of documents about that. So we tried to match these documents with data from Overton, which has, as I mentioned, data from policy documents from all over the world. So we extracted these DOIs from these publications from BV, from FAPESP. So the DOI from, I think most of you know what it is, but for those who don't, DOIs is the unique number that it's for this specific paper. So it is like a social security number for this paper. So we have information of almost 100,000 DOIs from documents published with financing from FAPESP with different universities. And we created this analytical workflow, trying to integrate that with Overton. It took us a little while to do that. We used different strategies. Again, I invite you all to read the paper for further clarifications on that. And we have some challenges, of course. It was very hard to analyze this much bigger number of DOIs, almost 100,000. It was also very, since we're using a very new database, Overton, we have to understand at every step what was the challenges involving Overton's coverage and Overton's meaning. So just a few results before calling Evandro here. So we have, as I mentioned, almost 100,000 DOIs from publications that were funded by FAPESP. We then got all of those DOIs, and we searched for them on Overton, and we got almost 3,000 of them that were at least one time mentioned in some public policy all over the world. And almost, a very coincidental number, almost 3,000 different policy documents from all over the world that were citing these 3,000 publications that was funded by FAPESP. Of course, we know that Overton has some limitations. This research was conducted with data through 2023, so they advanced from there to now, but they still have some limitations. They have some limitations on geographic bias, so there's more coverage on global north countries than in global south countries. Brazil has a low coverage, so only 1% of Overton's database covered some public policies published for the Brazilian government. And because of that, we know that we cannot necessarily imply that because some research is cited in a policy document, that this research has some impact in public policy. But as we discussed a lot in our research, is a proxy. It's a way to see that, as we discussed a lot, it's a different way to try to measure impact of policy, of science citations, but not citations in other publications, but citations in public policy documents. So we know that we have a lot of limitations, but we believe that our study allows us to see different things, especially we can now compare these results throughout the years and using different sets of DOIs to see the increasing, the changing impact of science in different policy documents. So we believe that the results are important, but the most important for us in the research is to create this method that allows us to analyze in a very clear way how a specific type of science is impacting a specific type of public policy. So I'll call Evandro to show you the results to you.
So thank you, Bernardo, and good morning to all. I will take the presentation now. It was a collective effort, so I will go to some results. We have more than that, so I invite to read the paper. We selected some results. So, for example, the first one is about the funding types behind the cited papers in policy documents. And it was surprisingly to us that we found out a diversity of funding mechanisms from FAPESP being mentioned in policy documents. So we have the top ones here. So regular research grants, but also individual scholarships such as postdoctoral, PhD, master's, and even scientific initiation type of scholarship originating papers mentioned in policy documents. Also, we have bigger projects, collective projects, such as thematic project research grant. So it was interesting to see that a diversity of funding types is really impactful when we are talking about the mention of research in policy documents. Of course, you know that we have the integration of these funding types. So we have, for example, postdoctoral scholarships linked to thematic projects and so on. But this kind of diversity of funding mechanisms and also the integration between them, it was interesting to see that they are giving a good measure of impact of the research funded in policy documents. The other interesting results that we found out, it's related to the correlation between the scientific impact of those articles mentioned in policy documents and the policy impact as well. So basically speaking, it's not a statistical analysis, it's just to see if there is some relation. But the articles mentioned in policy documents, they have better scientific impact metrics than all the samples. Of course, you have to be careful now with the analysis, because you know that Overton has limitations, Saival has limitations as well. Our methodology has limitations, so we are thinking about in responsive metrics, but it seems that there is a kind of relationship between scientific impact and policy impact as well. And we have to, not only us, but it's something that it's need more research to do, even in other contexts, to us understand more this relationship between scientific impact and policy impact. So going to the policy organizations that mention research from FAPESP-funded articles, we found out a lot of organizations mentioning research from FAPESP. The first one is Guidelines in PubMed Central, highlighting the role of FAPESP in funding health research. The second one is Food and Agriculture Organization of United Nations, so agricultural sector. Government of Brazil is in the 5th position here. It's a good position. We always have to remember the Overton coverage limitation. But we have World Health Organization, IPCC, some think tanks on public administration studies. So it's really diverse, the type of political organizations mentioning research funded by FAPESP, but with a good amount of them focusing on health, agriculture, environmental issues. So here we have also an international flow of this policy uptake from research. So we have a lot of policy documents from United States, United Kingdom, and Global North at all mentioning research from funded research, from FAPESP-funded research. Of course, we have also Latin America countries, Africa countries, and Asia countries as well. And of course, always we have to take in consideration the coverage of Overton on such kind of data. But it really brought to us novel data about the national and international flow of policy impact of the research. So we try to better analyze the articles mentioned by type of policy organizations. So for example, if we consider governmental types of organization, they mention more articles about health, such as species, treatment, also Brazil, cell, risk, and so on, patient. So governmental types of organizations, they tend to mention more research, health research. International governmental organizations, such as food and agriculture organizations from United Nations, they mention more research related to health, to agriculture, actually. When you go for think tanks, types of organization, they mention more research from FAPESP related to environmental issues, and we go to the others, we can see health research also being mentioned. Others here, it's almost all guidelines in PubMed Central, so this is why you have here more healthy research being mentioned. So going to the conclusions, of course our approach has limitations because of overtone coverage, but of course analytical limitations as well. We have other methods for assessing the impact of research on policy, qualitative, questionnaire surveys. This is one of them, using bibliometric techniques. But however, we could brought novel data about this national international flow, research policy uptake and impact from FAPESP-funded research. The role of diverse funding mechanisms was very interesting to see. So this, I think, we think that we have an institutional good implication on that, keeping this diversity, this integration of funding mechanisms. 3, we could found out that an alignment between the FAPESP's funding priorities with its policy impact. So we have here health, we have agriculture, we have here actually the thematic relevant areas and also environmental research. Of course, not only the results they are very important, but the methodology, as Bernardo said, is important because the idea is to trying to keep tracking, because overtone coverage is growing. We have to think in another sources, policy document sources and databases. So we think that our studies could shed light on the topic in the new methodologies to evaluate the impact of research on public policies. So I was talking about that, the replicability of our study. I think it's very important. So perhaps 5 years from now, we can replicate the study to see the results and so on. And of course, we hope that the results can try to inform or trying to strengthening the debate about measuring the impact of research on public policy. It's a important, very important subject, and we have to discuss further on this kind of evaluations. So just to thank you all, just to thank you Research on Research team. It was a collective effort, me, Sergio, Johanna, Bernardo, Karen, Sandra, Carlos, and Cesar. And we'd like to thank you, FAPESP, as well, not only because the funding, but it was co-produced with FAPESP people, Sandra, Carlos, and so on. So, thank you.
Thank you, Evandro and Bernardo, for the presentation. Before finishing this session, I'll just note that there's a lot to be done in impact analysis, because the words I heard from all the speakers included headache, nightmare, complex, difficult, not easy, and challenging. With that, I would like to invite everyone for lunch.